today we'll proceed with applying the Newton's second law of motion for normal and tangential coordinates. Last time we have used the rectangular coordinates to solve problems involving motions and the forces that acts with it using the rectangular coordinate system. However, today we will apply it using the normal and tangential coordinates. So if this is the path of the object, now the object is confined to move along this path. Therefore, if you apply the Newton's laws of motion in the binormal direction, so that is why summation of forces along the binomial direction is 0. Okay? So wala naglupad ning object ani. Now, also get the summation of forces along tangential and along normal, and you can now solve for whether if you're asked about the force or the acceleration. Okay, so how if the path this one, if the equation of the path is not given, so you can use this equation for to get the radius of curvature, provided that you have this equation y is equals f of x. Okay. Okay, so let's have an example. Now we will choose this example 13.7. Okay, you have a 3 kilogram disc D, this one, is attached to the end of a cord. So this is the cord. The other end of the cord is attached to a ball and socket located at the center of a platform. If the platform rotates rapidly and the disc is placed on it, so the scenario is the platform is rotating and you put the disc is placed on it and released from rest. Determine the time it takes for the disc to reach speed great enough to break the cord. The maximum tension the cord can sustain is 100 newtons. And the coefficient of kinetic friction between the disc and the platform is 0.1. Okay? So, okay, so the first step in analyzing this problem is to draw the free body diagram. Now, before I forget, the what is asked in the problem is the time that the cord will break. So the cord will only break when the tension exceeds 100 newton. Okay, so that is the scenario. So let's draw the free body diagram. This is the disc. Let's draw the normal tangential coordinate system. So this is the binomial normal and tangential direction. So the forces involved is that you have the first is you have the weight, and then you have the normal, you have the tension, and the okay, this is the tricky part, the direction of the frictional force. Okay, so ang frictional force is always opposite sa imuang motion, right? Therefore, so ang scenario is the platform is rotating and you put the disc. So aha ang direction sa imong disc ana. So kung mo ni ang platform ga-rotate ni, pagbutang nimo ana, ang tendency is ang disc mo go opposite sa direction sa imong platform. So ang platform nag-rotate pa na rotate counterclockwise. So ang disk nimo must be rotating clockwise. So ang imong frictional force karon mo i-oppose niya ni clockwise direction sa disk. Therefore, paano ni siya? Ang frictional force. Okay? So kung mali ang imong pag-draw, I hope clear sa inyo, no? Going diri ang frictional force. Again, mali nga free body diagram, mali po ang solution. So, zero na dayon. Okay, so let's apply the Newton's second law of motion. Summation of forces along the binomial direction. Okay, sa binomial direction, wala man naglupad imo ang disk along sa pattern na wala no upward movement. So, zero man zero. Therefore, the normal component is just the weight. Tama? Summation of forces along normal is equal to mass times acceleration normal. So, ang along normal, ang tension lang. Tension is just equal to mass times v squared over r or v squared over rho. Right? Therefore, ang v square ani karon ang tension nimo is 100 Newton man kay diri man mag-start mag-break ang coil. So 100 Newton times, by the way, 1 meter divided by ang M sa imong this is 3 kilograms. Tama? 3 kilogram. Okay. Divided by 3 kilogram. Okay, so sa may tabuhan ni 100, ang Newton nimo is this kilogram meter per s square. 1 meter over 3 kilogram. So, ang unit nimo will be m squared per s squared. Therefore, ang velocity is just 5.77. Okay. So, aha man gamiton na velocity mo ni ang velocity nga that would break, no? That would cause that cord to break. No? Okay, summation of force along tangential. So, along the tangential, kanina pong frictional force. So, mu kn mass times 80. Okay, ang mu k nimo is 0.1. Mu k is 0.1. The normal component is mg. So, mg, cancel ang m. Therefore, the tangential acceleration is just 0.981 meter per second squared. Okay, so man na to kuha ng time. Ang time is ako mo using the kinematic equation kani. Since start from rest man, so therefore 0 ni. Therefore time is just 5.77 over acceleration. Therefore, time is 5.89 seconds. Okay? 5.89 seconds. So, that's it. So, just practice, and there are many problems in the book. So, you just need to practice solving so that you will get familiarized with the equations.